Okay, this is going to be a video lesson on end behaviors of functions. Okay, we use this all year. It's a really core concept. I'm going to talk about first doing it, labeling an arrow, okay, and how to find the end behavior. Then I'm going to talk about how that relates to a function. Okay, so what I'd like you to do is draw these four shapes. And they'll come back to us in a little bit of the importance. Okay? Now, when we label arrows, we're going to label an arrow like it's a point. Okay? So, when we have a point, we label, okay, just like that. Okay? Now, all right, let me go to another page because I want to talk about how we label that point. Okay? We know this is an x value and a y value in a point. Okay? So, if the arrow is going to the right, we're going to label that x coordinate positive infinity. This reminds you of the interval notation. When it's going left, we label that arrow negative infinity. Okay? So that's what could fill into here. Now, this second part, if the graph is pointed up, we're going to label it positive infinity. If the graph is pointed down, we're going to label it negative infinity. Okay? So that's how we're going to label an arrow. Okay? So let's go back to our drawings. Okay? So, left or right, I have two arrows. Which one's the furthest right? It would be this one. So this would be a right arrow that's infinity. Okay? And now this arrow is pointing up, so that would also be positive infinity. For this one, this is a left arrow, so that would be negative infinity. Now, since it's still pointing up, that's also going to be positive. Okay? Let's go to this example. Which one's left, which one's right? Well, this one's the furthest left, so that would be negative infinity. This one is the furthest right, so that would be positive infinity. Sometimes people like to label the x ones first, okay? Now, what's this arrow doing? This arrow is pointing down, so that would be negative infinity. This arrow is pointing up, so that would be positive infinity. On this one, left and right, this is the furthest left. If you ever get confused with that, just hold up an L. The one that actually makes the L is the furthest left. Okay, so left, that'd be negative infinity. Positive infinity, left to right. Now this arrow pointing down, negative. This arrow also pointing down, negative. So you can see how that's a little bit different than that one. Okay, now this one, left and right. Negative infinity, positive infinity. Okay, all right. Now, this arrow is pointing up, so positive infinity. This arrow is pointing down, negative infinity. Okay, so that's how you label arrows. Okay, all right. Now, how do end behaviors come into play here? All right. Actually, let's stay on these examples. Okay. There's two ways you're going to see end behaviors. As x approaches infinity, y approaches, and there's a blank. X approaches negative infinity, y approaches blank. The other way they'll like to do it sometimes is they'll say x approaches infinity, f of x, which we should know from that that's just a fancy symbol for y. X approaches negative infinity, f of x approaches what? So these are just fancy symbols for y, okay? So how do you answer that question? Very easy. Where is the x infinity? The x is infinity right here, okay? And its corresponding y value is positive infinity. Where is x negative infinity? Right here. The corresponding y value is positive infinity. That's how you answer it. This one, as x approaches infinity, that would be considered this one. Okay? All right. The y is infinity. As x approaches negative infinity, which would be this one, the y would be negative infinity. Okay? So what I would like you to do is I would like you to pause this, this video, and I would like you to answer those questions for these two. Okay, I'm writing them down. F of x, I'm sorry. So what I'd like you to do, x approaches infinity, f of x approaches blank, x approaches negative infinity, f of x approaches blank. Okay, so take a second and fill out what you think those answers are. Okay, now this one is x approaches infinity, the y is negative. As x approaches negative infinity, this y is also negative infinity. As this x approaches infinity, this f of x would be negative infinity. As this x approaches negative infinity, the f of x would be infinity. Okay? All right? So that's how you do end behaviors. Okay? Now, functions, okay? Functions tie into those. Go ahead and write down these two functions. Negative 3x to the 6th plus 5x4. Okay? F of x equals 8x5 minus 3x4 plus 2x plus 1. Okay. Now, someone's saying, Mr. Evans, what are they ask you, okay, let's say this is question 1, and let's say this is question 2. All right, and they ask this. I need to know this stuff, and I'm not going to give you a calculator. Okay? They ask you these two questions. You say, well, Mr. Evans, I have no idea what those shapes look like. Okay? All right, I have no idea what those shapes look like. Now, what you can do is use those original examples we drew to help you. All functions that are continuous, we'll talk about discontinuous later on in the chapter. All functions that are continuous, their arrows are going to look like one of these 4 pictures. The thing could look like this. Okay? Sort of a crazy picture. But the end arrows, you still have a scenario that looks like that. So how do you figure out which one to use? Okay? You can label these if you want. We just did that, so I'm just going to do this very quickly on my own, just so we have something to reference. Okay, you already have this down. This is nothing new. We already did this part. Okay? So, the question is, all right, how do these tie in? All right, what you figure out first, all right, is the function, is the biggest exponent even or odd? Okay, so I look at the biggest exponent here is 6. Is that even or odd? Everybody knows that's even. This side of the graph are the even functions. This side are the odds. Why? This is usually like an x squared, and this is x. Those are first and second. That's how you can figure that out. This is an even function. That's an x squared, 2 even. These are odd functions. 1 is odd. So the first thing we want to figure out, is it odd or even? This is even. The second thing we want to look at is it. So that's the first thing. Second thing is the coefficient positive or negative? Okay? This row is the positive row. This row is the negative row. Okay? So, that coefficient is -3, so that is negative. So the picture I use is this picture. So x approaches infinity, y approaches negative, x approaches negative infinity, y approaches negative. Okay? Once again, that's a negative U shape, all right? Negative quadratic, all right? And that's a negative slope. That's how you know. Negative quadratic, negative slope. All right, let's look at this one. What's my biggest exponent? It's 5. That's odd. So I'm going to be in these. Okay? Now, my coefficient is a positive number. So I would look at this picture right here. So as x approaches infinity, y approaches infinity, x approaches negative infinity, y approaches negative infinity. It does not matter which is first, it's what is bigger, okay? All right, so what I would like you to do, okay, is answer, what I'd like you to do is try, okay, these 3 questions. And one of them is going to be a trick question, so be careful. Okay, for all these questions, I want you to answer this. Okay, so take a second, pause the video, and go ahead and do those questions. Okay, so biggest exponent is 2, so we're even. This is a positive number, so the shape you would choose would be that one. You have, I'm not going to go back to the previous example, that would be infinity and infinity. Okay, this one, biggest exponent, 7, so that's odd. The number out front is positive, so we would be dealing with this shape. Okay, so that answer would be infinity and negative infinity. Okay, this one you got to be careful. The biggest one here is 6, so that would be an even. Okay, now the coefficient out front, that is going to be a negative. So what I'm going to be dealing with now is that picture. So that's going to be negative infinity and negative infinity. Okay, the last thing I'd like to talk about, okay, is very simply is that this, okay, is the same as, and we'll talk a lot more about limits. These things are the same. Okay, these things are the same. All right. So as you look at end behaviors, okay, as you look at end behaviors, if they said, what's the limit as x approaches infinity of negative 4x to the third plus 5x squared? See, I don't know what that means. All right, which one does this tie to? Biggest one would be odd. Number out front would be negative. So what that would be, an odd negative, would be that one, would be that picture. Okay, so this is negative infinity, it's going up. This is positive infinity, it's going down. So what's the answer for this? Okay, well this is positive infinity, that result would be negative infinity. So that would be the limit for that one. Okay, so whatever the end behavior would be, okay, is what the limit would be. All right. So why don't you try to do one of those real quick? Let's say I said find limit of x approaches negative infinity of negative 5x squared plus 2. Okay. Take a second, pause. All right, go ahead. So that would be an even. And since that's there, that's negative. So that picture would be this. So negative, negative, positive, negative. So the answer is, what it would be is that x approaches negative infinity. Okay, very simple. That's going to be negative infinity, our answer. Okay, so nothing overly complicated. All right, so that's how you would do end behaviors. I think it's a very vital skill.